Students, in this quick little video, I'm going to show you how to do a hypothesis test for comparing the average from your sample to a population average. So what we're going to do is look at question 6. How often have you experienced, what does it say? How often have you experienced academic struggles as a student on a scale of 1 to 5? Or in this case, it's actually 0 to 5. The average turns out to be 2.79, which on our scale is 2.79, right between, let's go back here. This was a scale, always, often, sometimes, rarely. So 2.79 is right between sometimes and rarely. So closer to that middle point sometimes. Let's develop an hypothesis test. Now, generally, hypotheses, the claim comes from the client, or it could come from research that you've done indicating that so many people or the average of responses is equal to a certain value. Because of the time limits within this course, and because of what's happened in the last few weeks, we haven't been able to set aside good hypothesized claims. So if you are going to do a test where you're comparing the sample average to a population average and you need to know what that population average is, either send me an email or a text and I can look at the question. I can give you a good perceived or assumed population value. So in this case with question 6, we have the sample data. The average is 2.79. The median we don't need to worry about. The standard deviation, though, is 1.19, and the total sample size is 106, which means that every student in our survey, answered this question. So let's take a look at what we would do for this. So I'm going to use this other spreadsheet which I made available to you. I'm just going to write up here, bigger letters here. Let's also increase this. So the null hypotheses. We're going to assume that the population average is 3, that your client or research shows that the average response to this question is 3. So let's make this one-tailed test, and of course that comes also from your client or from research. But you could say that we're going to use words here instead of symbols. A population average for question 6 is at least 3. The alternate hypothesis is the opposite. Population average is not at least 3, basically meaning that it is less than 3. If you remember from statistics, which I hope you do, there's various symbols we could use in that, but for the case of what we're doing in this course, this is sufficient. Keeping in mind that the alternate and the null hypotheses are always opposite of each other. Alpha is, I can't type today, it's always said to be at 5%. That's what we're going to use for all of our hypothesis tests. You should also be able to determine that this test is a one-tailed test. So we have our sample average. Let's just go over here. We have everything here. Remember from the last file, the average turned out to be 2.79, which is less than 3, but is the difference significant? We have a standard deviation of 1.93. This is the sample standard deviation. So whenever we have the sample standard deviation, whenever we do not have the population standard deviation, which we don't, we have to use a sample standard deviation. And whenever we use a sample standard deviation, we use a t value instead of a z value. So this is T alpha. Sample size is 106. Population average, as given, is 3. We are assuming that it is at least 3. We know that's a one-tailed test. So when you look at this file, this hypothesis test file, this data comes from either the question or the client. The value of 3 is a value from the client, and if you're doing this type of test, as I said, contact me and I'll give you that population average. So if you enter these values in yellow, the critical value 1.659 will pop up based on the formula and on 5% level of significance. And there is our test statistic, negative 1.812. It is, when we make our decision, we always compare positive values. So this t-value, this t-stat, would be equal to 1.182. The critical value, right up here, remember critical value is that t-alpha value. Critical value is 1.659. Because the test statistic is greater than the critical value, it leaves us with the decision to reject the null hypotheses. Right here, our decision rule: reject the null hypotheses if the test statistic, right there, 1.812, is greater than a critical value of 1.659. So we are rejecting this. This basically would be rejected. We are left with this hypothesis, which basically says that the population average is not at least 3, that it's actually less than 3. So the client or research that shows that the population average is at least 3 is clearly wrong in this case. You can also cite the p-value, which is based on this calculated value of 1.182 equals 0.0364. Our decision rule right there to reject it if the p-value is less than alpha. It clearly is, so we would reject it. Your decision rule, even though there's 2 of them, will always give you the same decision. So as a point here, reject hypotheses, decision is made. It means that the hypothesis has been proven incorrect, and we have enough evidence to go back to our client and saying that the average response for question 6 is not at least 3, basically meaning that it is less than 3. And in this type of question, would definitely prefer, with this one here, how often have you experienced academic struggles as a student? Basically showing that it is less than sometimes, so goes into that rarely area. So, which is good because it does show to the college that perhaps they have sufficient academic resources, or students are accessing them, or students are perhaps doing better than some areas may think. So that is how to do a hypothesis test comparing the sample average to the population average.